Welcome to base angle theorem, and we're going to learn about parts of an isosceles triangle. So an isosceles triangle has at least two congruent sides. Notice that word that's underlined. This is in your notes. I want you to underline it too, the word at least, two congruent sides. So at least means you can have two congruent sides or you can have three congruent sides, which means that an equilateral triangle is a type of isosceles triangle. So an equilateral triangle is an isosceles triangle with three congruent sides. So if an isosceles triangle has exactly two congruent sides, the two congruent sides are called legs. We don't call them legs in an equilateral triangle because it's hard to figure out which two would be the legs. Right? We want to call them all legs. So we only call two sides legs when it's an isosceles triangle with exactly two congruent sides. And the ones that are called legs are the congruent ones. The other side, the one that's not congruent, is called the base. Right? So the side that has a different measure is called the base. So there, oops, I kind of outlined the base. Right? So that's the base. Along the base, these angles are called base angles. And those angles are special. The base angles are always the angles that are opposite the two congruent sides. Right? So the angles adjacent to the base are the base angles, and they're always opposite the two congruent sides. The other angle is called the vertex angle. Right here we have the vertex angle. Right? And so that angle is opposite the base. Or you can think of it as the angle included by the legs. Right? So opposite the base, this one here, that's the vertex angle. Right? That's the one that has a different measure than the rest. The others are called base angles, and they have the exact same measure. Right, so base angle theorem, and you put a little star in your notes. This is in your notes. If two sides of a triangle are congruent, the angles opposite them are congruent. Right, so for instance, if AB is congruent to AC, right, that means that we've got two legs, two sides of our triangle are congruent. Oops. I was just trying to outline. There we go. Right. Then the angles opposite those two congruent sides are going to be congruent. So in other words, if AB is congruent to AC, then angle B has to be congruent to angle C. There we go. I didn't do a very good job. So I want to darken it a little bit so you could see it. The converse of the base angle theorem, so converse, remember, just goes the other way. Okay, so it just goes the other direction. And what goes the other direction? Our hypothesis. I should be specific. So our hypothesis goes the other direction. And that's just what converse means. So converse of the base angle theorem, if two angles of a triangle are congruent, the sides opposite the triangle are congruent. Okay? So in other words, let's say we're not told that AB is congruent to AC, and we're just told that angle B is congruent to angle C, and we're wondering, gee, is that an isosceles triangle? Well, if you have two angles congruent, then those sides opposite those two angles are congruent, and you have an isosceles triangle. Okay? Let's prove that. Right? So I don't want you to take what I say, just because I want you to believe what I say just because I say it. Right? We're going to, as much as possible, prove things to be true. So you can see it's not just I made them up or, it sounds like a good idea. It's actually been proven to be true all the time. All right, so we're going to do a little proof here. This is in your notes. I want you to write the blue writing there that's not in your notes. right? Because we're going to use one of the proof blocks in this particular note. Actually, we're going to use more of them than just one. We're not going to write it in that format. We're not going to write it as a flow proof. We're going to write it as a two-column proof. But I want you to remember one of the proof blocks. And the reason is, I'm hoping that by remembering the proof blocks, you'll recognize how to make connections from one idea to a related idea. And that's what the proof blocks do. So we have a big idea here, our goal. And put this in your notes. Actually, so put the blue writing in there. And that is, so we have the two boxes there for the two blanks. With the bar over, because it was a line segment, is the bisector of angle blah, blah, blah. And that's the definition, and we're using in this example a definition of an angle bisector. Because we know this to be true, so because this is true, right, this statement here, then, I'm going to put a little asterisk here so it continues over here, then this statement is true as well. Right? So if we're given that some segment is the bisector of an angle, right, using the definition of an angle bisector, I guess I'll star that one too. Right, so using the definition of an angle bisector, we know that we have two congruent angles, right? And those are the angles that are created by our angle bisector. So I want you to start thinking of, and making connections so that when you see one piece of information, you recognize that another piece of information is true because of it. And that's the beauty of the proof blocks. But anyway, so I wanted to just kind of step back for a moment and explain why I put the proof block up there. And now let me go to our big idea, which is why the proof block is up there, right? So, or why that particular proof block is up there. Our big idea here is to prove the triangle's congruent to prove the base angle's congruent. And a big part of that is going to be the definition of an angle bisector. All right, so now let's go to our proof. All right, so, and this is going to be true in any triangle where my two given pieces of information are true. In most proofs, we start off, generally when we do a proof, when we complete a proof, we start off with our given information, so don't rely on the givens, but often it's just usually good to get those on the table, so to speak, and get them right into our proof so we can use them as we need to. All right, so my first statement that I'm going to make, is that AB is congruent to AC. And these really should have segment lines above them. I just have a little bit of trouble typing them sometimes. All right, so AB is congruent to AC. Would you put that in your notes? Also want you to put that, write that, AD is the angle bisector. I'm going to abbreviate angle, and you can too, right, with the symbol. So my I looks a little too much like an E. Is the angle bisector of angle BAC. Right, so put those two statements in your notes. The reason we know those to be true, why those were given to us. Somebody told us, right? They told us this happens to be true. I think these are, no, I can move my reason here. Just a little crowded. I'm just going to move it over just a smidge. It's generally a good idea to go from what you're given, right, to why is that important. Right? So let's look at our first statement. AB is congruent to AC. It's marked on our diagram. But if it wasn't, we should mark that in our diagram. Anytime you've got information that you can mark on your diagram, it's a good idea to do that. And the reason that that's important is the only way that we can get part of a triangle to be congruent is if we can prove the whole triangle is congruent. Right? And we're going to need three pieces of information and a side, a pair of corresponding sides that are congruent. That's an excellent piece of information. Right? So for right now, all we're going to do is, with AB is congruent to AC, is mark that on our diagram, and so that we can remember we have a pair of congruent corresponding sides. Now let's use the second statement. AD is the angle bisector of angle BAC. Right? And so now we go back up to that proof block there, which is why I put that proof block up there. Right? Anytime you have the statement that some segment is the bisector of an angle, your next statement should be angle BLOP is congruent to angle BLOP. And in this case, right, so AD here is our bisector. I'm going to just outline AD so you can see that. Right, there's AD. If it's an angle bisector of angle BAC, it means it divides angle BAC into two congruent angles, and it means that these two angles are congruent to one another. Right? So because we've said that AD is the angle bisector of angle BAC, we can say that angle BAD, angle BAD, is congruent to angle CAD. Oops. I have no idea why my hand wrote an S. I was thinking CAD. And the reason that we can make that statement is because of the previous statement. Right? Well, how do we explain that we're using the previous statement? It's the definition of an angle bisector. That's what an angle bisector does. It divides angles into two congruent angles. That's its only job. It's the only thing it does. Just divides angles all day. Right? So into two congruent angles. So definition of angle bisector. That's how we know that to be true. So now we've done as much as we can with our given information. Right? We've got a pair of corresponding sides. We have a pair of congruent corresponding sides and a pair of congruent corresponding angles. Right? But that's not enough to prove our triangle is congruent. We need one other piece of information. Right? Not going to be able to get another pair of angles congruent. Right? We don't have any vertical angles here. There's no parallel lines. But there is something that we know is congruent. Anytime you have something as feature shared, an angle or a side, shared by two triangles, it has to be congruent to itself. Right? So the first two pieces of information, they were given to us. I'm just going to put those little G's there just to kind of remind you. The third piece of information, the first piece of information was given to us, number one there. Number two came directly off of this statement here. And number three came from our diagram. It was a picture clue that AD is congruent to AD, and we know that to be true using the reflexive property. All right, so now that's actually enough to prove our triangle is congruent. Those are the three pieces of information we need. Right? So we now know that triangle BAD is congruent to triangle CAD. And the reason we know that, we've got two sides. We have the included angle. Notice it's between the two sides. It's formed by those two pairs of congruent sides. Right? So that would be side, angle, side, triangle, congruence postulate. And you might think, well, why did we prove triangles congruent? We weren't trying to prove triangles congruent. We were trying to prove that base angles are congruent. Well, you can write this in your notes too. If you want to get corresponding parts of a triangle congruent, or you want to show, I shouldn't say get. You're not really getting them. They're doing it all by themselves. You're just showing. So if you want to show That's a much better word. Corresponding parts of a triangle are congruent. You need to prove the triangle's congruent first using a congruence shortcut. Our 5 congruence shortcuts. Side, 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 angle, angle, side, angle, side, angle, and hypotenuse leg. A congruence shortcut. Once we have the triangles congruent, we know all of the corresponding parts are congruent, because that's what it means to be congruent. All of your corresponding parts are congruent. Therefore, I know the base angles are congruent, but let's name those angles. Angle B is congruent to angle C, and those are the base angles in the triangle. How do we know? They're opposite if we pull away we consider this to be one triangle instead of two, right? Our angles here are opposite. Right? So we're proving base angle theorem. Right? So those are the angle B and angle C are the base angles in our triangle. And we know that angle B is congruent to angle C using, now we talked about this early on when we were talking about congruence. Matter of fact, it was in congruence transformations before we even started proving triangles congruent. We had we talked about that if you prove a triangle congruent, you know that all the corresponding parts of the congruent, I'm going to abbreviate here, triangles are congruent. Sometimes it's also abbreviated as CPCTC, but make sure you know what those letters stand for when you're using that, right? So now we have done just what we set out to do. We proved the base angles are congruent. All right, so now you do not have to take me at my word. We were actually able to prove it by proving our triangles congruent. So because the triangles are congruent, all the corresponding parts are congruent, and therefore these two angles are congruent. Hey, we did it. We would also know, by the way, that BD is congruent to CD, and that angle BDA was congruent to angle CDA. All right, so now that we've proven base angle theorem, and make sure you understand this proof and ask me if you need me to review something, because you might see it in a benchmark or a formative or a test. Just hint, hint, hint. Now that we've proven base angle theorem, let's use base angle theorem. All right, so converse of base angle theorem, if two angles of a triangle are congruent, then the sides opposite them are congruent. We went over that before, but just a little reminder. Now we've proven it. And then corollary to the converse of the BAT, we're just abbreviating base angle theorem. Don't use that abbreviation. They can use it only because base angle theorem is earlier in the page. A corollary just means like a little attachment, a little extra piece. Right? So because equilateral triangles are a type, they meet the requirements for an isosceles triangle, anything that applies to isosceles triangles would apply to equilateral triangles. Right? Other than things like we don't call two of the sides legs, because all three are congruent. That's kind of confusing. Right? So in your notes, I don't know if it's in there. I put notes there, so that leads me to believe it might not be. But if this is in your notes, then just put notes about. Just put a little star by it, and the words and vice versa. If this is not in your notes, write this in. So if a triangle is equiangular, remember equiangular means all three angles are congruent. Then it is equilateral, and equilateral means all three sides are congruent. Now, it's 3 because it's a triangle, right? If a quadrilateral is equiangular, then it would be all 4 angles, but this is a triangle, right? So, if a triangle is equiangular, it's equilateral because equilateral triangles fit the definition of isosceles. They have at least 2 sides congruent. Right? So anything that's true for the isosceles is true for the equilateral. All right, so let's use that base angle theorem that we have proven and learned about to figure out which sides are congruent in our triangles. Okay? So we're given some information, some angles congruent, and we know using the converse of base angle theorem, if the angles are congruent, the sides opposite them have to be congruent. All right? So I'm going to mark and erase after each one, otherwise it might get a little busy here. All right, so we're given angle 1 and angle 2 are congruent. All right, so if you're told that and you've got overlapping triangles like this, just follow angle 1 and angle 2 to the sides that create them, and you know that these sides have to be congruent. So if angle 1 and angle 2 are congruent, then EB has to be congruent to EC. And these are segments, right, so we need to use the correct symbols. All right, so problem 8. Problem 1, first problem, or problem 8, because that's what its number is done. All right, let's try problem 9. All right, angle 3 and angle 4. All right, so don't get confused because there's lots and lots of triangles. Angle 3 is this angle here, and angle 4 is this angle. Right, we don't go beyond that. If they wanted us to go beyond that side there, they would have indicated by making an arc showing that. Right, so angle 3 and angle 4 right there. All right, so you just go across the triangle to the opposite sides that are creating angle 3 and angle 4. Right, and that means that EA is congruent to ED. So let's write that. EA is congruent to ED. And lastly, I'm going to erase this so we don't get confused with all the markings on there. Angle 5 and angle 6. All right, so angle 5 and angle 6 are located right here. Right, so we just go across the triangle to the sides that created them. And now this side is congruent to this side. All right, so that doesn't go all the way down, right, because this is the triangle. And so that's the triangle. These are the two congruent sides because those are the ones that are opposite the congruent angles, according to our given pieces of information here. So that means that EF is congruent to EG. And there we go. All right, so anytime you know that angles in a triangle are congruent, the sides opposite those angles are also congruent. All right. And so there we go. I think I will, before I leave this page, just mark them, the sides in the colors, but nothing else. So here was EA and ED. In case you look back at this PowerPoint, this was EB and EC. Right, so those were congruent. And then, well, now it gets interesting because EF and EG were this much, right? And so I guess I'll just put 3 marks on them. Right? Right, so there's just finding which sides are in a triangle are congruent using base angle theorem. Now we're going to use it to find some measurements. All right, so we want to solve for the measures of angle X and Y. All right, angle X is the easiest one, so let's solve for that first. All right, so we're going to first of all use base angle theorem. And some of these are in your notes. I don't have your notes in front of me. You follow along. All right, so base angle theorem says that angles opposite congruent sides are congruent. All right, so therefore, X has to be 35 degrees, right? Because it's one of the two angles that are opposite those congruent sides. To find Y, we're going to use triangle sum theorem because we know the angles in a triangle add to 180 degrees. And I'll write that. Just a little review. Angles, in case you forgot since the last lesson, angles in a triangle add to 180 degrees. And I won't keep writing that. I'll just write that, the definition of triangle sum theorem one time. All right, so that means that X, which is 35 degrees, plus the other 35-degree angle, plus y, have to add to 180 degrees. 35 plus 35 is 70. And if we subtract 70 from both sides, right, we have, I'll write that in there. I should have really written this a little further up. I thought I would use this space. Let me just move this one out of the way. On the bottom here, there'd be plenty of space, but I write too big. There we go. Now you can see it and it's not coming off the screen. All right, so we'll just subtract 70 from both sides to isolate y. So we have y equals 110 degrees, and there we go. We're done with this particular problem using base angle theorem, triangle sum theorem. All right, so most of our problems here, well, all of our problems are going to involve base angle theorem, and many of them will also involve triangle sum theorem. All right, so we want to solve for x and y. Here, y would be the one to solve first. All right, so we're going to use base angle theorem. Oops. We need the rest of the word angle. I'll abbreviate theorem though. Base angle theorem to find the measure of y, which look to those congruent sides. So we know that if one base angle is 72 degrees, since these angles have to be congruent, the other base angle is 72 degrees. So y is equal to 72 degrees. Right, and then we'll use triangle sum theorem to solve for x. And I'll just abbreviate theorem. Right, so we have x plus 72 plus 72 equals 180. 72 plus 72 is 144. If we subtract 144 from both sides, x is equal to 36 degrees. And there we go. Another problem done. Let's do another one. All right, so what are the measurements of the base angles? All right, so here we don't have any of the measurements of the base angles, but we do know that because these angles are opposite congruent sides, they have to be congruent. So we could name them the same thing. Right? We don't know what they are, so we'll name it with a variable. How about x and x? Right, so whatever I name one, I should name the other the same thing, right? Because they are equal to one another. Right? And I'm just going to remind us that. So base angles of an isosceles triangle are congruent. Yep. So as we're going through here, if it's in your notes, please add it, anything I write on the page. But if it's not in your notes, it's optional, but you certainly can for some extra notes. All right, and sometimes I give a little extra for extra notes. All right, so x plus 70 has to add to 180. So here we're kind of using, let me use which theorem we're using. We're kind of using them together, I would say. We're kind of using triangle sum theorem. That's why we set it equal to 180. And we're also using base angle theorem. That's why we labeled them with the exact same variable, right, and not two different variables. So triangle sum theorem and base angle theorem are being used at the same time here. Right, so x plus 70 is 180, so let's add out like terms as I move things around. So x plus x is 2x. And then we can just subtract 70 from both sides. That means 2x is equal to 110. And then if we divide both sides by 2, x is equal to 55 degrees. All right? And so those are our base angles. They both measure 55 degrees, right? Because they equal x. Right? If any of these problems aren't making sense to you, please just ask me about them in class, and I'll review it with you. All right, so this one's a little tricky problem. At least it looks like a tricky problem at first. Notice we don't have any values at all, and you want me to find the measurements. Right. So maybe that a little bit bigger there so you can see. All right, so now you're going to use your sides to find your angles, and we're going to be using, first of all, we're going to be using base angle theorem. Now, the variable to solve for is definitely y. You go to try to solve for x, you'd be like, I know which angles are congruent, but I don't know what they are or how to find them. But we can definitely find y, because we've got 3 congruent sides, which means all 3 angles have to be congruent. So this is base angle theorem, but this is as it relates to equilateral triangles, which are a type of isosceles triangle. Right, so since all 3 angles have to be congruent, every one of them is y. They're all y. Right, so now that we figured out the base angle theorem part of it, that they're all the same measure, now we're using triangle sum theorem too. You really can't use one without the other here to solve this problem. Right? So if we add those together, because they all have to be exactly the same, if the 3 sides are the same, right? Equilateral triangles are equiangular and vice versa. So we have 3y equals 180. We divide both sides by 3, and y is 60 degrees, right? Or 60. Right? And we talk about it as an angle as degrees. If we just want to say y is 60, that's fine. All right, so now that makes this a lot easier to solve. All right, so I'm going to actually write next in the triangle here that y is 60 degrees. And you might be thinking, okay, we figured out y, but how does that help me with x? All right, so we had a couple ways to solve this one. We could use, so 2 ways come to mind. One of those is exterior angle theorem. Okay? And the other one of those is a linear pair. Let's do both of them, right, to see if we get the same answer. All right, so now we're going to switch from y to x, right, and while we can't solve x directly, we could solve for this one using y, right? So together, notice they make a linear pair. I'll leave it as a question mark. So now we're using linear pair postulate. I'll spell the word postulate. All right, so y plus question mark there. And we know what y is, so let's, instead of using y, let's use 60. So 60 plus question mark has to equal 180. If we subtract 60 from both sides, question mark is 120 degrees. All right, so if question mark there is 120 degrees, we can go back to base angle theorem, because we know that angles, I got to write around the 120 there. Angles opposite congruent sides are congruent, right? And so these are our base angles. They have to be congruent to one another. Okay? And so now, I really need to write smaller. All right, so now we're going to use base angle theorem, because I want to solve this 2 ways. Base angle theorem and triangle sum theorem again. I'm going to try to, no, of course, I wanted to just grab everything at once, but no. All right, sorry. Just giving myself like an inch of space. Move that up. You know how it is. There we go. All right, so we know that those angles opposite this congruent sides are congruent. So we've got x plus, this would have to be an x. X plus 120 has to add up to 180. So x plus x, that's 2x, plus 120 equals 180. If you subtract 120 from both sides, you have 2x equals 60. And if you divide both sides by 2, x is 30. That's the longer way to solve this problem. Right? We had to do this one. This step was necessary. But now we have an option. We can do these 2 steps. So this is option 1 that I showed you. right, was to do these two steps. Option 2 is to do one step. But this one step is going to require us to use a different postulate. Not linear pair, not base angle theorem, not triangle sum theorem, but, well, actually a little bit of base angle theorem. I lied about that. So base angle theorem, yes, but not triangle sum and not linear pair, but instead exterior angle theorem. And we can do this instead of having to solve for the angle we weren't asked to find. We can just solve for x. All right? And to make it easier, I'm going to erase all our work, all our hard work. Well, I can leave the one triangle up, but I'm going to erase this stuff. And I'm not going to erase the writing, just the stuff in the triangle. All right, so we have this triangle here is 60 degrees. That is an exterior angle to this triangle. I'll outline it. This angle here is an exterior angle. It's outside that purple triangle. So it's exterior angle to the purple triangle. I'll just make a purple triangle. All right, so that means, so using base angle theorem, that has to be x, right, because it's opposite the congruent sides. X plus x has to add up to 60 degrees, right? Exterior angle theorem. So exterior angle equals the sum of the two remote angles, right? The ones that aren't next to you. The ones that you'd have to get off the couch to get. All right? So that means that x plus x is equal to 60, and that means 2x is equal to 60, and x is equal to 30. All right? So this is option 2, which is why I show you more than one way, why it wasn't enough just to know triangle sum theorem. Look at how much more work with bluing we had to do with option 1. We have all the blue work and all the green work. Or we can just do option 2 and just do the purple work. All right? So sometimes there's more than one way to solve it, but maybe one way is easier than another way. And in this case, exterior angle theorem was definitely much easier, because we don't care what the other angle is. I'm going to end this podcast, but I'm not done with base angle theorem. I don't like my videos to be too long, and this is pushing it. And so there's not too much more. So join me in a very short video where we finish off base angle theorem. All right, so bye for now.